Good afternoon. So today I will talk about how daylight was used as a concept and a design driver for a high school project in the city of Enköping in Sweden. I work at White Arkitekter in Stockholm, and in this project we addressed many challenges, not only for the daylight quantity and quality, but also for the process of being integrated in the design process itself. We had high ambitions in this project for achieving good daylight and healthy environments both indoors and outdoors, and we decided that daylight and sunlight are key factors that we will focus on in this project. Because in Sweden the weather is most of the time dark and cloudy. And this is a photograph by the Swedish photographer Kent Lisch that I saw in the Ethnography Museum in Stockholm. And it made me think again about the indoor environment that we're creating and how it affects our health and well-being. And it was a constant question that we addressed in this project. So in the presentation, I'm going to talk about how we integrated the simulations within the design process, the simulation tools and the interoperability between software, and some of the results that we had, and some conclusions and recommendations. And just to give you a brief introduction about White and about myself, White is Scandinavia's leading architectural practice and the third largest in Europe, with projects across Europe, America, and Africa. And I work in Stockholm, but I'm part of a digital sustainable team with different people in Stockholm, Malmö, and Gothenburg. And we work with different types of simulations and also with research and development of tools internally. And this project was special because I was involved in the project from day one, from when we were deciding on the program. And I worked both as an architect and as a sustainability specialist in the project, actually. And I would like to give special thanks to the architecture team for allowing such an opportunity to happen. So starting with the design process, we had a holistic and iterative design process where we would simulate different alternatives, analyze the results, and inform the design. And at such an early stage, we focused mainly on the sunlight and microclimate outside the building, and also on the daylight levels achieved on the facade. And when we reached to a final designed option, we did more in-depth studies for the daylight, wind and comfort, preliminary energy, and photovoltaic cells using solar radiation to estimate the potential for the use of photovoltaic cells. And all of this was thanks to the tools and methods that we have developed internally that are part of a package that we called Inform. And they're part of, there are four tools. Two of them are on the urban level and another two are on the building level. And the first one is used to simulate sunlight hours outside the building and also thermal comfort. And the second one is used to simulate the daylight and sunlight outside on the facade. And on the building level, we have a tool for simulating daylight factor, and it's only daylight factor because that's based on the Swedish regulations, unfortunately. But we aim to do other simulations usually when we're involved in the design process. And the fourth one is early stage energy indicators that includes the form factor, average U value, and also primary energy based on steady-state energy calculations. And this project was a pilot project where we have used the four tools to inform the design decisions iteratively the whole way. And we also discussed within the design team questions of interoperability between tools to exchange information between to make sure that we have an optimized process for exchanging the models and to make the simulation process much easier. And this actually helped in reducing the number of hours that we have used for the simulations. So we used 3 times less when we were doing the simulations in comparison to if we have done it at a later stage in the project. So like I've mentioned, we studied different alternatives, and these are the 2 of the alternatives that we have studied. And we've also analyzed the sunlight hours received outside and implemented different daylight concepts within the project. Until we reached to one building form, and we integrated also sustainability concepts that were dependent also on the sunlight exposure, such as maximizing the unshaded roof area for photovoltaic cells, and maximizing the sun exposure in outdoor areas, and having green roof for biodiversity. So one of the things that we did was that we simulated the sunlight hours, and these are the total number of sunlight hours that will be received on the exterior ground on the 21st of March. And as you can see, even though that we have worked a lot with optimizing the form, we still had a challenge of achieving enough sunlight hours in 2 of the courtyards that were important for us in the design. And on the images on the right side, we have also highlighted in yellow, first, the 5-hour threshold, and that is to have at least 5 hours in the outside areas, and that was a recommendation from Boverket in Sweden. And below, we have a 2-hour threshold that was recommended by BRE in the UK. But still, we could see that we did not have enough sunlight hours. However, in Sweden, in March, it's usually cold outside, so it can be maybe maximum 5-6 degrees, so people don't spend so much time outside. So I've also analyzed the sunlight hours in May. And from there, we could see that, of course, the results got better. But one conclusion that we had was that it was hard to derive a threshold for informing the design based on the Swedish climate. And parallel to that, despite that we didn't have a metric for evaluating the daylight at an early stage when you are optimizing the building form, we did a vertical sky component to fine-tune the design that we have decided, and to vary the building heights and the building positions and sizes to maximize the daylight exposure on the outside facade. And from there, we could see that there would be some challenge in meeting the daylight requirements in the ground and the first floor over there in these courtyards, and also some challenging in meeting the daylight requirements facing the newly developed context. However, this context is still going to be planned, so we had an opportunity to inform the design team and also the municipality of the distance between our building and the newly developed context. And after that, at another stage, we did a daylight factor simulation. And in this stage of the project, we only did the daylight factor because, like I said, this is present in the Swedish regulations. And in this project, we were aiming to reach Miljöbyggnad Silver level, and that is a Swedish certification system that is similar to LEED and BREEAM. And we were aiming to, in this project, to have a 1.2 daylight factor threshold. And when we talk about 1.2 daylight factor, that means that we would need to have, according to the Swedish regulations, a 1.2% daylight factor in the middle of the floor plan. So the lines that are in white are the 1.2% daylight factor, and then the purple area in the middle represents the maximum room depth that you can have in each of the floor plans in all of the volumes. And I will not go in details in this because we would still need to optimize the atrium that we're having and also the position and the size of the skylights. But I've made this image as a summary of the results for the 4 floor plans and for each of the building volume that you have, A, B, C, D, with the percentage of the non-daylit area and the percentage of the daylit area. And you could see that on average for the whole building we had approximately around 80% daylit area, and that was because we optimized the building form at a very early stage and we didn't wait until a later stage when it would be hard to already alter the design. And at a later stage in the project, when we work more with the program in the next stages, we will also add the areas with the daylight requirements that are needed for each floor plan, so that we make sure that the program, the areas in the program that need daylight are fulfilled. And I also did a comparison with the new European standard. And to simplify, this is the floor plan that I've shown before. This is plan 2 with 30% glass-to-wall ratio. And I forgot to mention that in the simulation for the daylight factor, we used 30 to 35% glass-to-wall ratio, and that was based on a recommendation of the preliminary energy analysis that we used using a steady-state calculation. And that is because we also have very strict requirements when it comes to the energy. So we can't just work with the daylight, we need to work with the daylight and energy in an iterative way. And from there, so this is, so this line is the 1.2 line, and then the blue line is the maximum room depth that you can have in the different facades. And we could reach up to 8 and 7 meters depth. And after that, to go into more details, I've added some rooms that are 7.2 times 8.4 meters, and the 8.4 being this depth over here. And we could see that then this 1.2 line is approximately in the middle of the space as required in the Swedish regulations. So in most of these rooms, we would meet actually the daylight factor requirements. And the gray areas are the areas that wouldn't meet the requirements. However, in the back of the room, you can have different circulation or storage areas also. And this was done using a 40% glass-to-wall ratio. And then we also evaluated the median daylight factor. And you can see on average that the median is between 1.1 and 1.2%. And in comparison to the new European standard, this median value requirement is 2.5, which is far off from what could be actually achieved. And just to test, we could only achieve this value using an 80% glass-to-wall ratio. So in conclusions and recommendations, optimizing the use of tools within the design process is a key factor towards the daylit space and comfortable outdoor spaces. And working interdisciplinary is essential at an early stage. And from that process, we're working both as an architect and as a specialist. It gave a lot of input, both to the architects to understand more how we work with light and about the daylight requirements, and also for me to understand how what are the requirements that the architects need to inform the design in a correct way. And it's also a challenge to meet the European standard in the Swedish climate. Thank you.